If I know that all the radii have to be equal, and the radii has a length of 18.3, if this length is x and 6.3, that would be x plus 6.3. We know they have to equal 18.3. So you just subtract the 6.3 from each side, right? And x would equal 12. So this little piece is 12. On this software that I use that creates these worksheets, if they put this 18.3 shifted, that means the radius is 18.3. But see here how they have it right next to the center? This means the diameter is 32.4. Okay? If the diameter is 32.4, how do I find the radius? So I'm going to divide this by 2, which would give me 16.2. So the radius has to equal 16.2. All the radii, and here's a radius, right? So this is done the exact same way. That 16.2 has to equal x plus 8.6. So all you do is subtract 8.6, and that will give you your answer. What is the answer?
I got 7.6.
7.6? 7.6, is that the answer? Okay.
I'm sorry.
Sure, go ahead.
You said it shifted.
Okay, see how this is right next to the center?
Yeah.
That dot? That means diameter. Do you see how this one was shifted where here was the diameter, but over here they put it on as 18.3? So that's why I know they said that the diameter is 18.3. I mean the radius. And see, they did it again over here that they showed you the radius was 18.3. If you are ever confused on whether or not, especially on a quiz, if they're talking about diameter or radius, ask me and I'll tell you which one they're talking about. I wish they would put I wish they would put it up here, the diameter versus radius, because it does sometimes make it hard to see the difference. So for 1 and 2, just to summarize, we had to know that all radii are equal, right? And since this one had 18.3 as the radius, and this radius was x plus 6.3, we could set x plus 6.3 equal to 18.3 and just subtract to find the answer. Over here, the diameter was 32.4, so this one had an extra step. I had to divide it by 2 to get the radius. I know now that all radii of the circle has to be equal to 16.2 because this is also a radius. I just said x plus 8.6 is equal to 16.2, and you subtract. We got it? Great. Okay, so now we have this one. Nope. This x is from here to here this time. And x is not a radius. Does everybody agree that x is not a radius? Is from this point over to here. But because it's perpendicular to this little segment that's going from the center, we know that this segment cuts this length directly in half. So this is also x over here, right? Okay, we have a right triangle that is missing one leg. I can use a squared plus b squared equals c squared to find the missing length because this is 90 degrees and this is a triangle. Remember, your c is always across from the 90 degree. It's always the longest side. So this is c right here. I could call the others a and b. Now I could substitute in. So 7.7 squared plus x squared has to equal 15.5 squared. So if I use a calculator here, I know that 7.7 squared, or just multiply by itself, either way, is 59.29. And now I have to do the 15.5 and square it. So 15.5 x squared is equal to 240.25. 240.25. What do I do next? I have to subtract 59.29 from both sides. So, or just from here, you could just do it here. So x squared is equal to 180.96. And then you need to take the square root of that because it wouldn't make sense to do the square root on this calculator. You have to do second square root 180.96. And I get the answer of 13.5. Right? So this would be 13.5. Make sense or doesn't make sense? Now, how do you know whether to do a squared plus b squared equals c squared or just subtract like we did up here? What was the difference? The x was on the radius, right? This one, x was part of the radius. On this one, is x part of the radius? No. And that's when you know you would have to use a squared plus b squared equals c squared. So this next one, you would do the same way. I would label my hypotenuse, and then this would be a, and this would be b, and you could do x squared. Oh, that's ugly. Let me start over. X squared plus 13.1 squared is equal to 14.6 squared. So x squared plus 13.1 x squared is 171.6. 171.61 is equal to 14.6 squared. 213.6. 213 point, what was that? 16. 16. And now I'm going to subtract. What was it? 41.55. And then take the square root. X is equal to 6.4 6.45, which I'd round that to about 5. Yeah. So 6 point,
I got 6.445, so 6.4.
oh, it should be 0.4. Oop. We just rounded incorrectly there. There, let me fix that. 0.4. Okay, there we go. How are we on those? Coming back? Was it a good idea to review it?
Yeah.
We'll review more tomorrow too, of course, with the do nows and just throw on. Okay. Now here it says determine if AB, so here's AB right here, right, is tangent to the circle. That means if I extended it, it's only that A would be what we call point of tangency. What would happen if this is tangent? This would be a right angle. If A is a point of tangency, if this line was tangent and this is coming from the radius, this would have to be 90 degrees. So I could use A squared plus B squared equals C squared again to check. If it does equal, then we say, yes, it is tangent. If it doesn't equal, we say, no, it is not tangent. So again, we use A squared plus B squared equals C squared. Across your longest side is what you would make your C squared, right? So this would be C, and I would label this as A and B. So we're just checking, is 6.5 squared plus 7.2 squared equal to 9.7 squared? Are those equal? So I'm going to use my calculator. 6.5 squared plus 7.2 squared gives me a total of 94.09. 94.09. Is that equal to 9.7 squared? Oh, look at it is equal. So because they equal each other, we would say, yes, it is tangent. Yes, AB is tangent. Did I go too fast? Are we good? What do we know about these type? We have a point. It said assume the lines appear to be tangent are tangent. Do you see that instruction? And it says solve for x. So they're saying that this line is probably tangent, right? And this line is tangent. If I have two tangent lines drawn from the same point outside the circle, then these lengths have to be equal. So you just set these two equal. Am I going to use 11.4 at all? No, I'm not even using this. All I do is set those two equal to each other, right? So -2 plus 7x equals 5x plus 4. Right. So remember, when you solve and you have variables on both sides, you get variables to one side, constants, which are the numbers without the variable, to the other. So I subtract 5x on both sides. I get negative 2 plus 2x equals 4. I add 2 to both sides. 2x is equal to 6. Yep, you divide by 2. X is equal to 3. Now, if it asked what the lengths were, you would substitute in. Sometimes it's nice to substitute in just to check your work. 5 times 3 plus 4 is 19. And a negative 2 plus 7 times 3, is that also 19? Yes, because 21 plus a negative 2 is 19. So we know that it worked. You didn't have to do that. Okay, so I love these. These are puzzles. Miss Dawn loves puzzles. I know that it says here, assume lines which appear to be tangent are tangent. So from here to here has to be the same length, right? So if this is 9, this inside from this point to this point is 9. And the reason why that's handy is I need this length over here. If I kind of wrap around and find all the tiny segments, I'll find some of the missing segments that aren't listed. And then I just add everything on the outside. I won't be adding this 9 in red because that's why I placed it on the inside, because that's part of that 13.8. But what is 13.8 minus 9 to find this little segment here? 4.8? So that means this part is also 4.8, which was handy because I needed this length right here, right? Now this is 8.7. So now I'm going to label this here, this inside is also 8.7. So now if I subtract these two, it gives me this little piece right here. What is 11.7 minus 8.7?
3.
And that means this little piece over here is 3. So now, because it wants perimeter, only add the outside. This little piece that I didn't know is 3. This is 9. This whole length here is 13.8. This little piece was 4.8. This is 8.7. And then this is 11.7, correct? So add all of those little pieces together, and that will give you the whole perimeter. I always double check, make sure I put in all of them. 8.7, 4.8, 13.8, 9, 3, 11.7. Okay, I got them all. Did everybody get 51?
Yes.
So the perimeter is equal to 51.
Question.
Yeah, that's why they're there.
Yeah.
You're sweet.
I'm sorry.
Oh, because this is 8.7 here. That means this piece from here to here is 8.7. So if this whole segment is 11.7, you subtract these two pieces here, and it gives this little thing here is 3, which also makes this 3.
Thank you.
have all the segments here, right? But we're missing this segment right here. But to get that, I'm going to have to walk all the way around to find missing pieces because this segment and this segment would be equal. So this piece here is 6.5, right? Because of this point here. Subtract 11.8 and 6.5. That'll give you this piece. What is it? 5.3? So that means this side is 5.3. So now if you subtract 13.3 and 5.3, this is 8. So then this piece is 8. See how when I talk about wrapping around to find the missing? So now you add all the outside pieces. Know why I like these so much. I think they're fun. Anybody else think these are fun? Somebody does? Okay, and I double check. I have the 6.5, the 11.8, 13.8, and 8. And now I press enter. Did everyone get that the perimeter was 30? What was that? 39.6? Yep. Woohoo! Okay, so let's go ahead and hand these out because they have circles on them, or you can use their pencils. Hold on 1 second. With the second. I'll send this to you. We are ready for test. Yeah. I guess because of that. And I say I love birds, but I guess if that's ever happened to you, why you would have an yeah. If you need anybody from here, yeah, that wouldn't be a bad idea. Okay, so I handed out, okay, so now I'm gonna draw a circle. Where's my shapes? Oh, shapes. Circle. Oh, I love this. Look, it even showed me showed me where it was, kinda. Okay, there, up. I didn't want to do that. Is there an undo? Okay. So, right here is and I'm going to label my center O, right? Okay, so everybody draw a circle, label your center O. I noticed some people were mislabeling, so that's why I wanted to go that's why I put this one back on here. So it says draw a radius and label it as OR. So the R should be at the end and the O will be at the beginning. So here's O2. I'm going to label this as R. So, I saw some people putting OR just right next to it. No, that you need points. 1 point is O, 1 point is R. Now I'm going to draw a diameter. Does it matter where that radius was, by the way? No, you could have drawn it here, here, here. When I look at yours, not everybody's is going to be the same, and that's okay. What? There you go. You learned something. So now I'm going to draw a diameter. A diameter, the endpoint should be on the circle, right? Then I'm going to label the endpoints as DM. Tangent. So tangent would mean somewhere on the circle. This would be harder to draw. I'm not going to be there's a way to actually construct it with a compass, but we're not going to get that exact. I just want you to be able to recognize. So from this point, it should only touch at that point, right? And then now, yeah, mine's kind of bendy and it shouldn't be, but, and then this is TG. So 1 point T, I'm gonna put another point over here is G. And then what's a secant?
It goes through it a little bit.
Yeah, it passes through the circle at 2 places, and it should be a line. Secants tend to be lines. So I'm going to go ahead and draw just anywhere through, and I'll put little arrows on the end. And I will label that at somewhere. I'll put a point and label that as S. Somewhere put a point and label that as C. You could have had it the other way around. That's fine. Because SC and CS would be the same as long as you have your points on there. And that's what I would be looking for. Right? It's kind of like knowing your vocabulary. Any questions on that? Thursday, yeah. You're going to be just fine, but I think a D because it's not like a prerequisite for a next course. Well, you are fine. I have a test to grade to put in there.
So we don't
You
have
had
to
a
have
0 for the test. I'm sure I'll be fine when I grade the test. Oh, you'll be fine.
We don't have to have a minimum of 80%.
We try to get you to get 80 because that's like your goal.
Okay.
But to actually just get by, you just need a D.
Okay.
I
want my 8
correct. That's good. Have high expectations. Yes. You could have had it on the other side. What I'm looking for is it just touches the circle. So yours would look different than mine. Okay? The only thing is when you label them, make sure you're putting points on your line. Because what I was seeing was people just putting like OR next to each other instead of putting points. Does that make sense? Okay. Okay, so we are ready for today's lesson. After today's lesson, we'll probably have a little bit of extra time if you want to work on your construction project. And I could show you how to do that last part with the lid. Because I brought my really big scissors and I cut the lids. Killer scissors? I don't think so. Yes. Sure. No. We have one more test next week as project, but we worked on a little bit of project. Yeah, you have one more test on circles. We may throw in some transformations, which are rotations and flips. Um, and then, so this Thursday's your last test, and then next week is just project. Okay. Well, it's we have a couple projects. You did the trig project, which I have in here, and then after the test, you were handed a construction project. You still have to do one more part with the lid piece, and then during the next week is a Pictionary dictionary. You will work with one person because you're going to pair up because there's not enough computers for everybody to have their own in the lab. And you get to make a dictionary based on a theme. And I give you a bunch of words. I will show you an example and I will give you the words. So you'll have to make 25 slides. You will find pictures with that geometric term in the picture based upon your theme. So, like, I have my example is a chess one. This person loved chess, and every single picture he found the dictionary or he found the geometry term, typed up the definition, and then showed the picture of it. But then each picture had to deal with um, chess. Somebody already said they were going to do food. Was that you, Heidi? Yeah, Heidi said, "Oh, I'm going to do food." I've had a couple people do food in the past. Art is a good one. Architecture is a good one. I would love to learn more about the Chin culture. So please inform us by using maybe pictures from your culture, and that would help me. Like if I were to do one, I would probably do it about crocheting because I crochet all the time if I were to do my own. Okay, does that make sense? I will. I will. Unless you want to see it now. I mean, it's right here. I'll pull it up. Sounds like everybody's interested now, so I'll pull it up.
Are we gonna be able to access this part from home?
Yes.
Okay. Cause I'd like to start mine.
After I do the first slide, we're gonna represent this.
Yes, and you will present it together with your partner. So you'll be presenting it at the board. Yes, you will present it. So let me view slideshow. So see, he saw an acute angle right there, and this was the chessboard, and then see, you put an angle that measures less than 90 degrees, and then here adjacent angles. He was talking about the British flag right here, where these were because he presented it and then explained it where this was. Radius. Where do you think the radius was? The clock, yeah. See the hands of the clock? That's a radius. Congruent. They were two congruent pieces, right? Square. And of course, he had his definition. Line segment. Reflection. Because that was a reflection. Diagonal. Octagon. You see the octagon?
Yeah.
Line would be like lines are hard because really it's only like out, yeah, because it goes on forever and ever. Array, circle, right angle, arc. So because we've been talking about arcs, a plane. I should have taken off what you have to use different pictures. You can't keep using the same picture. I want different pictures. Cylinders. Look at it. Those are cylinders. That was interesting. What?
I'm thinking noodles.
A cone. So he pointed out the cone was right here. Pyramid was the case here. Rectangular prism. Now that is a funky looking chessboard.
So we gotta put what it is and then the definition, and we gotta put a website with it?
Well, well, that was so that you're not plagiarizing. So he documented his website.
Is that for the picture, the website?
Yeah, that if you
Okay.
clicked on it, that's where you got the picture.
Okay.
Oh.
So what if we get our own pictures? We don't have to.
You don't have to do that.
Okay.
I had one person do it all of their daughter, and it was all pictures of her daughter. It was cute. And then she ran out because if you make it too specific, it's hard. And I told her, well, what cartoons does she watch? And you can find cartoon things, I think. And so then she went ahead because she was like, I'm stretching here. This is a central angle, which we'll learn about tomorrow. Obtuse angle, point, diameter. He drew this on there, by the way, to show it. But like I said, you will be presenting. So you and your partner will be up there taking turns, showing us what shape you're talking about. Base. And that was it. Most people enjoy this. I haven't had a whole lot of people say they hated it. Because they get to choose and they get to work with someone. The only thing that they tend to complain about is presenting it. But it's good to practice because in senior seminar you have to present. But I'm giving you a partner to help you with your anxiety.
Miss Dawn.
Yes.
That's rotisserie chicken for me.
There you go. Okay, so I'll give you the list of words, but basically, I don't care. You could use any geometry term that we've used, but I give you just a list just to help you think. It's not the only word you can use. So that's what I did. What do you think? Think you can do that?
What program do you use? Google?
Google Slides, so you can share it with me so I can grade it later. Or I'll grade it maybe while you're presenting.
And that is accessible from the Google Classroom?
It's accessible to your drive. When you open it up, you should be able to go to your drive. See when
What would
I
I look on Google Classroom? So
oh,
I know
it
what
wouldn't be
slides
Google
I have to
Classroom. When you log into your email, you should see this, and you can go to your drive. And then when you go to new, you would do a Google slide.
do. Okay.
Okay. Are we all good with that? Okay. Oh, well, I want to close that and I want to reopen it with Cami.
Miss Donna,
Yes.
so we have to work with a partner on this.
I said you three could work together. I said earlier, yeah.
But this is the thing I'm trying to get to, is that this does seem like it's gonna be time consuming.
We have all next week.
Oh, okay.
Just you have to present it by Thursday.
But we don't need to spend time on it at home since we're gonna.
You're going to be using the computer lab.
Okay.
You can't. I've had students like get together
Okay.
because they just didn't want to come in, and I don't care if you get it done, you get it done. So, does that make sense? Okay. Open with.
We're on Google Classroom, but we refer back to the other one so we know what slides we did.
No, I'm going to print out.
Oh, okay.
I just haven't gone. You guys are faster than me.
I would totally start it tonight. Or finish.
I'm going to I'll print it out for you. I'll print out the list of words. Which video? The review? The review. Because they played it in class. I pulled it up. You may want some. I've had students. Andrea says you can't pull it up from Google Classroom either, but she joined my YouTube
Yes.
channel and she can pull them up directly from the YouTube channel. So try joining my YouTube channel. Okay. Oh, because I don't have a final exam video, because we don't have a final exam. Because we do a project.
Okay.
I used to do a final exam and I thought, forget this, we're gonna have fun and do a project.
Your channel, I just don't know how
Yes.
to get to it.
Make me rich and famous. Well, if you go to YouTube,
Just don't judge
just
mine.
general, you can just, you can look at all the ones you subscribe to. Now, if you really, really don't wanna do the project and do a final exam, I can print out a final exam and actually have you do it.
Yeah.
No, thank you.
This is so much.
Final exam or project?
Project.
No, the project, no final exam, unless you want. You want a final exam? And you have to teach me about your culture, I'm counting on that. I will hand you, instructions, I just haven't labeled yet, okay? Yeah, and you'll have all next week, we're going to go to the computer lab, and you work with one other person, because there's not enough computers for everybody, and then you will present it to,
I wanna get
you to the partners will
I
present.
don't wanna present well, I just wanna make it.
Last time I was, have I never helped him? Have I ever said, no, I won't? Yes, do you have everything on it?
Oh. Yeah.
What? What, Jake?
I don't wanna do it.
Yes. Oh, if you were that good, yeah. You're gonna use, you wanna use like, are you gonna use like Canvas or something? Some other, yeah.
Oh, also the manual cut out reading.
You can do it, you can do it. Go ahead. Google Slides. And share it.
Yeah.
Okay. Everybody have their notes? It's really easy to confuse arc length and arc measure. There's a difference. I'm gonna wait until everybody, I think they're all talking about their project.
You got us started.
I know. It's very exciting.
No.
See, cylinder, 3D. My favorite cylinder, my coffee mug. Okay. Shh. Okay, there's a big difference between arc length and arc measure. I'm going to be going over those, but make sure you know the difference. The only time you should look back is to see how far you've come, which is excellent for this class because this is for most of you. Sorry, Blue, not you. Your last math class. What math class did you start with when you first came? Wow, you've come. Do you think you've learned a lot of math?
Yep.
Yeah, you've come pretty far. It's pretty awesome. Hmm? You didn't? What did you start with? Pre-algebra. But you went through pre-algebra, algebra, algebra 2, and now geometry. That's a lot. Congratulations. Okay. So today we're going to talk about arc length, arc measure, central angle. We're also going to talk about sector area. That wasn't in here, but we are going to be talking about that. Sector area. On there. We'll be there. Okay. So, central angle is an angle with the vertex at the center of the circle. And you have two sides are radii. The sum of all central angles in a circle is 360. The degree of an arc measure formed by the endpoints of the central angle is equal to the central angle. So if this is 90 degrees here, the arc at intercept, that arc measure is also 90 degrees. Now, right now, I am going to ask you to take out a piece of paper, just scrap paper. If you need some, I can give you some. And we're going to do a little experiment. We're going to use a compass.
More formula. Tomorrow is my HCC test. Yeah. I have to come in. I hate that too. I think it's
Okay. Now you have a protractor on your geometer, but if you'd rather use a different one, I'll just place them right here. Okay? So either protractor will work. So we are going to do a little experiment, and you are going to use your compass and draw a circle. So I'm going to go ahead, take my compass, and I'm just going to draw a circle. And that's all you're going to use the compass for. Okay, we're not going to do any more constructions. Now, I want you to use a straight edge, and we are going to create a central angle. So I want you to draw two different radii to the end point on the circle, something like that. Okay? Then I want you to measure that angle. So mine's about 76 degrees. Yours probably would be different, right?
I have a 90-degree angle.
Mine is 76 degrees, but your guys's should be a little different because it's not the exact same angle. Oh, so why isn't this working?
What made you not draw the 90 degree?
Just because I wanted it, because this will work for anything. I
Okay,
just
wanted to.
no.
Yeah, cause I
No.
accidentally made a 90 degree.
Okay, so what would this arc here would be the exact same measure. Will everybody agree with that? That's what it stated in our theorem, that the central angle and then the arc that it intersects would have the same degree, because it's all based upon the circle being 360, right? Okay, now you're going to listen carefully. I'm going to just do this just so that way you can see it a little bit better. Do you see how you have the endpoints on the circle here? Okay. What I want you to do is now I'm going to ask you to take a straight edge and take a point on the opposite side. So I want you to just draw a point on any opposite side. And you are going to connect like so. So where it intersected the circle, I want you to draw segments to that new point you created. And then I want you to measure that angle.
What point do we start at?
Well, the vertex was always where you start at.
For every point
What do you mean I just went the
Like-
angle.
over here, and do we do this one too?
I think I need a new pad. This one's not working. Either that or the point. This is 30. 30. That's not letting me. There.
There's two.
No, mine was 38. Ah, it's ugly. Mine was 38. Heidi said hers was 45. What is yours? 36. Was yours about? Was yours 72 degrees originally? Okay. What relationship are you noticing?
Half of the amount of the 90 degree, or what, well,
Of
whatever.
the
yours is.
central angle.
Yeah,
Bring it over here.
it is half of the amount.
Did we all notice the exact same thing? Try doing it again. Just take another point, just put it on the outside of the circle, and just random, and then remember you're joining from the two original points that you intersect. And then try measuring that angle and see what happens. Mine's a little bit off. I gotta make that a little bit more accurate. There it goes. See how I just made a new one, and I was just checking to see if it always worked. And look at that. Mine is 38 degrees. What's yours? Yeah, I don't know if it's this program or my pen. Yeah, this should have been 38. Called inscribed angles, by the way. Or if I have it.
Mine is this one. What's this one? 30? This one's 60. Yeah, so this one, and this is half of it. This one is.
This is not, either that or this isn't clean. I don't know. So, and those are called inscribed angles, by the way. Can you say that with me? Inscribed. So we have two types of angles we just talked about. Central angles, right? Central angles are the same as the arc it intercepted, but inscribed angles are a little different. They have the vertex on the circle, right? Or let me go back to my picture. These in red are inscribed angles because the vertex is on the circle. This one's a central angle because it's from the center. Okay? And what was the relationship again that you just found out? What was the relationship? It's half.
Half of the point, the first one.
So it's half of the central angle of this of the arc, same arc it intercepted. Did you find that interesting? Good. Okay. Here we go. Okay, and we'll be talking more about central angles and inscribed angles. But this is not on your notes. Please there should be room on the top of your notes to write this. Minor arcs are arcs less than 180 degrees. You only use 2 letters. And that'd be the smaller arc. Major arcs we label using 3 letters, and those are usually greater than 180 degrees. And this isn't on your notes, but you will have to know that for when they start talking about major and minor arcs, or when you are labeling arcs. So little arcs, 2 letters, larger arcs, 3 letters, right? You see the picture? Does it make sense? When they're talking about the arcs, they're talking about the circle, the part of the circle. So if you're doing food for your Pictionary dictionary, part of your crust could be an arc, right? Hint, hint. Or a full pizza, that crust could be the circumference of the circle. Okay. Oh. Sorry. Jordan, were you here Thursday to take your test?
Yeah, I was. I didn't know.
Where's your test?
I gave it to Miss Leah.
Oh, Miss Leah?
Well, I didn't test it or anything.
Okay. Do you want to take Jordan to work on his test?
I can come in. Are you busy at
Well,
lunchtime? Or
okay.
are you busy after, or this time are you gonna be here after school?
I could help you 4th period.
Alright, I'll do that.
Okay. Can I move on now?
Do you have a pen I can use in this time? I can give it right back. No, I got one in my Miss. Thank you.
Okay.
I'll give it back.
Okay, so central is 112 angle, 112 degrees right here, right? What is this arc then? What is this measure here? That one's also 112. Let's just be that software, because now I can write just fine. That maths pad that I use. Oh, it wouldn't let me draw. Okay, now here, HJ. Is this going to be a major arc or is this going to be a minor arc? Major. Which major means it's going to be larger than 180. So F, H, G would be going all the way around this outside. And I'll trace it for you. Here's F. I'm going all the way around, right? To G. F, H, G is this whole arc here. Well, if from here, if this is the central angle, that's 71 degrees. What's this out here?
71.
And if this is 45, what's this one out here? So you have two choices. You could subtract 360 and 49, and that should give you the rest of the circle. Or you can add 71, 40, 45, and 155. And that will give you the length of that, or that'll give you the measure. Yes? Oh, it said J. Oh, I'm sorry. I thought it said G. See, bad eyes. Let me redo that. Oh, I did a little bit. Let me get my eraser. Oop. Ah.
It was the same on the outside.
Okay, so let me try that again. I thought that said G, and it's J. So, but it would be this way around then. Sorry. Yeah, and I had to go in order. F, then H, then J. It wouldn't be this one. It's around the outside. And sorry, I just
360 minus
so it'd be 49, 150, 45, 40, or you could just subtract the 71 and 360, and either way you should get the same answer. So what's my answer? 360 minus 71 is 289. Or you could add them all together, as long as whoever made this PowerPoint made sure it would all work out. Or you could have done 49 plus 155 plus 45 plus 40, and I should get 289. Yep, either way. Right? Any questions on that?
Messed up my paper.
Which one? Your investigation?
Cause you did it the wrong way and I.
Oh, well, I could give you a new one. You want a new one? I'm sorry.
Thank you.
And after you get the answer, 360 minus that one.
Okay, now over here. What do you think happens when you have a diameter? It cuts it in half, right? Diameters cut circles in half. So each one of these, this side would have to equal 180 because this is a diameter. And so it cuts the circle in half. And if you take 360 and divide it by 2, you get 180. So if I want to solve for x, how would I set this up? 29x plus 6 has to equal 180. So you would subtract 6 on both sides. You would get 29x equals 174, and then divide by 29. So x would equal 6.
So that 70 degrees don't matter?
Correct.
Okay.
Just to confuse you,
Yeah.
to make it high school level,
I see.
to distract you. Any questions on that?
I think these are equal.
Okay, now look at this. Is it talking about an arc? Everybody say no. Because look at here. If I back up, see how this had an arc above the FHJ? That means that it was talking about the outside piece, that measure, and it's talking about degrees. But here, what's it talking about when I have this notation? Angle measure. Very good. Angles of the arc or central angle indicated. They want the arc of T, not arc, angle TVS. But I have X. What am I going to do?
Equal to each other?
Are they equal to each other? Do they look equal? They have to equal 180. Why do they have to equal 180 when I add them together? Right, this is a diameter. And when I have a diameter, and I know it's a diameter because it's going through the center of the circle, this side has to be 180, this side has to be 180. So when I add these two together, I could find x and then substitute x back in. So this is a multi-step question, multi-step problem. So 13x plus 11 plus 7x plus 9 has to equal 180. And so I'm going to combine my like terms. 13x, 7x is 20x, plus 11 plus 9 is 20 again, is equal to 180. So I subtract 20 and then I divide by 20. Am I done with just x equals 8? I am not. I get the answer, but what did it ask for?
I get TDS.
TVS, which this angle and this arc measure would be the same. So if the measure of angle TVS would equal 7 times 8 plus 9, which is 56 plus 9, which is equal to 65 degrees. So this is 65 degrees here, and it's 65 degrees here, because the central angle and the arc it intercepts have the same measure, right? I'm trying to pull that up for you.
These are notes, right?
Yes.
Okay, good.
Did I do inscribed angles yet? Maybe that'll be for tomorrow. Oh, I guess I didn't do inscribed angles. What? This? You're good? Okay. Find the measure of the arc or central angle indicated. But EF, all I have is 3x plus 4. What? How am I going to find that?
Can
X.
it work it the same way as the problem before and find find out what X is, work out that problem, and then you'll have your arc.
Okay, but I don't have a diameter. Oh, you are so smart. She said the magic number of how much is in the whole circle? 360 is a whole circle, right? And so if I add all the pieces together, it should add up to 360. So I would do 30x plus 4 plus 51x minus 1 plus 114 has to equal 360. Why was I going to put 180 when I just said 360? Okay, so now you're going to combine your like terms. What's 30x plus 51x? 81x. So now I'm going to have to do the numbers now. I have 4 minus 1, which is 3, plus 114, which would be 117, right? Because you have a minus 1 here. 4 minus 1 is 3, plus 114 is 117, and then you have 360. So I have to subtract the 117. 81x is equal to, what's 360 minus 117? 243. And divide.
By 81, it'll be 3. And then you wanna take, the EF, the 30 times 3 plus 4.
Yes. So once you get 3, did everybody get 3? Or are you still working on that? Now you have to substitute it in because it wanted this arc measure here. So you had to take 30 times 3 plus 4, which is 90 plus 4, 94 degrees. Okay.
So what was the answer, Ms. Dawn?
94. So now we're going to talk about arc length. We'll probably do inscribed angles tomorrow. Arc length is a formula. An arc length would be like the actual measure. So if you were to take a piece of string and wrap it around, find the actual length of that arc. So like a piece of string then stretched out to lay it flat. So it's the circumference formula times the fraction, which would be the degree of the central angle over 360. So arc measure is just the degree, right? Arc length is an actual measurement, like with a string or tape measure, however you would actually measure it. So let's try this. So it's saying this is 15 meters, right? And the formula was 2 pi r times, they use theta, that's a Greek letter for theta. Yes. I shouldn't talk and write at the same time. That's when that happens. 360, excuse me? theta. Theta is just, it's a Greek letter that means degree. When we were doing trig, you may have seen me write a theta before. It's just they use a different letter when they're talking about degree. It doesn't matter. You can use an X, right? Because, yeah, it's called theta. So, what's the radius? 15. And what is the central angle? 150, which I'm going to place up here. So it'd be 2 times pi times r, which is 15, and then times 150 divided by 360. And that would give you this measure right here. So if I bring up my handy dandy calculator, and we know that usually on CUDA they use the calculator pi. So 2 times my pi is over here times 15 times what, 150 divided by 360. Right? And then when I press enter, we'll go to the tenths.
Okay, so 39.3?
Yep. So, and this would be meters, 39.3. It would not be degrees because it's a measure. So it'd be meters.
No square?
Nope, because it's just a length, like with a ruler or tape. Nope, that would be volume. Square is 2-dimensional, volume's 3-dimensional.
So no points?
Length is 1-dimensional. This is 1-dimensional. Okay. Are we good? Can I move on to the next one?
Miles.
Miles. Boy, this is a huge circle. 15 miles. Huh. Maybe it's part of the moon. Who knows? Right? I don't know what it's talking about. Okay, yeah, this would be the same. So it'd be 2 times pi times 15 times 60 over 360. Hello.
So you got 75.4 kilometers. Or kilometers.
So this one was what? 15.7 miles. And they just gave you one more. So this one was, again, 2 times pi times 16 times 270.
Divided by 360. 75.4 kilometers. Kilometers.
Again, I have no idea what circle's that big. But like I said, it could be talking about the earth. I don't know.
The measurement around the
Could be circular mountain, volcano,
Yeah.
maybe a volcano.
Or maybe that's the center of the earth.
Now, before flash drives, everything was on DVDs or CD-ROMs, right? And we'd have areas of sectors. This would come into play a lot if you were in, but yeah. So the area of a sector. So sector is part of a circle. So what we were talking about was the outside, right? Like the crust of a pizza. This would actually be the pizza pie itself, the slice of the pizza. And so this is area. And it's based on the area formula of a circle. Well, the area formula is pi r squared. And now you're just doing a fraction of the circle. So it'd be, it's the same thing we've been doing, other than now we're doing pi r squared with the central angle divided by 360. So if I wanted to find, and this would, now we would use square units though, because you're talking about area. So this would be what, 90 over 360 times pi times 14 squared. So I would get 90 divided by 360 times pi times 14, and don't forget to square it. That's a common error. 153.9.
I didn't do it right, so I don't know.
Oh, we don't round?
Do you get 4 for?
I did round.
153.9, I thought it would be 153.
No, because this 3 behind the 9 is less than 5. So this would be 153.9. And then it'd be feet squared. That's good. That's why I didn't like when I first came in here, all the desks were like this. Everybody would, and I'm like, that's horrible for adult ed. Anything you know about teaching adults, they should be at tables. And that was the first thing I did when I got into this room. I'm like, that's not gonna work. Okay. Did everybody get 153.9 now? And now it'd be square units because we're talking about area. We're talking about, and when we're talking about sector area, that would be this whole thing here, right? I didn't do inscribed angles on this one. Interesting.
Maybe 178.
176.
Oh, 177.
Yeah. I wanna see how she does it.
This one?
Well, we got the answer, but see, okay, you said by the 10th,
Okay.
this one's a 9, it would turn to a circle and that, or a 0, and that would be a 7, right?
I'll get it up here. Just give me a second. I can only do one thing at once. You're okay. So you are correct. This would be 177 because this 7 bumps up this 9, but that 9 has to be bumped up to a 10, so it'd be 177.0 yards squared. Okay.
This wasn't too bad, Miss Dawn.
It isn't too bad.
Not too bad.
Okay, go ahead and take a break. When you come back from break, we'll.
How long?
Oh, yeah. Well, that's what happens in geometry. Everything seems easy, and then when you start putting it all